Welcome to our podcast, where we cover unique and interesting stories for you. In this episode, we will discuss and reveal new proof that Asteroid Bennu came from a wet world. The tiny space rock, known as Asteroid Bennu, continues to unravel unique insights into the history of the early solar system. The samples of Asteroid Bennu collected by NASA's OSIRIS-REx revealed its past and adds to the already known information about the space rock. Researchers have reported the detection of magnesium-sodium phosphate. This came as a sheer shock, as it was not detected earlier by the spacecraft from orbit. This bolsters the theory of Bennu being a splintered-off chunk of a much larger primitive ocean world. Some phosphate minerals were found on the asteroid sample from Ryugu as well, as collected by the Japanese Space Agency's Hayabusa 2. They have also been found in meteorites. But Bennu's case is different because of its minuscule size. The presence and state of phosphates, along with other elements and compounds on Bennu, suggest a watery past for the asteroid. Dante Loretta, co-lead author of the paper and principal investigator for OSIRIS-REx at the University of Arizona, Tucson, said in a statement, "Bennu potentially could have once been part of a wetter world. However, this hypothesis requires further investigation." OSIRIS-REx gave us exactly what we hoped: a large, pristine asteroid sample rich in nitrogen and carbon from a formerly wet world, added Jason Dworkin, a co-author on the paper and the OSIRIS-REx project scientist at NASA's Goddard Space Flight Center in Greenbelt, Maryland. There are many reasons for the team to consider Bennu a piece of an ocean world. One is the presence of serpentinite, a type of rock that forms when molten rocks combine with water, just like in the mid-ocean ridges on Earth. There are also a lot of soluble substances, which appear to have been shifted by fluids, and we can add to that the conformation of phosphates. We're still coming up with ideas on how to test the wet parent body hypothesis. But to me, it's the leading candidate for the geologic environment that these rocks formed in, Professor Loretta told IFL Science in an exclusive interview. The sample of Bennu continues to be distributed to labs in the US and around the world. In March, the team presented 58 findings from the initial analysis of the asteroid, and new insights come out almost every week. The Bennu samples are tantalizingly beautiful extraterrestrial rocks, said Harold Connolly, co-lead author on the paper and OSIRIS-REx mission sample scientist at Rowan University in Glassboro, New Jersey. Each week, analysis by the OSIRIS-REx sample analysis team provides new and sometimes surprising findings that are helping place important constraints on the origin and evolution of Earth-like planets. He further said, "Thanks for tuning in. If you enjoyed this episode, be sure to subscribe and share your thoughts in the comments. Stay connected for more exciting discussions and updates in our next podcast."